Hello everyone. So let's discuss the given problem. I'll mark the important points here in the question. That is, given the angular width is 60 degree, right? And the width of the slit is 1 micrometer. Now we have distance from the screen is 50 centimeter in a Young's experiment, and the fringe width is 1 centimeter, right? Now let's discuss the solution. Given to us is that angular width is 60 degree, that is 2 alpha and alpha. 2 alpha is equal to 60 degree, right? Now, and alpha is equal to 30 degree. A is the width of the slit here, that is 1 micrometer. D is equal to 50 centimeter, distance between screen and the slit. Okay, now the condition for minima, that is path difference delta x, is equal to a sin theta equal to n lambda, right? We'll put the given values and find the answer. All these values are given and we are taking n equal to be 1. Okay, so lambda is equal to 0.5 micrometer. Sin theta is equal to 1 by 2 into 1 gives us 1 micrometer equal to 0.5 micrometer. When we use the same set of YDSE, the values of D and lambda would remain same, right? Now we will use these values to find the fringe width beta in YDSE. The formula for fringe width beta is equal to lambda capital D upon small d. Given the small d value, small d is given to us as small d, that is what we need to find, right? So we'll what we'll do what we will do is cross multiply, that is take d on the right hand side and 170 centimeter to the denominator. Lambda is equal to 0.5 micrometer, hence the value 0.5 into 10 to the power minus 6, and capital D is equal to 50 centimeter, that is 0.5 meter upon 170 centimeter, that is 0.01 centimeter, giving the value on calculation 25 micrometer. Hence the answer is D equal to 25 micrometer.